This Balloon Racer sample file was designed in Tinkercad and previously sent to Fusion 360 where we modified the design further. We're now ready to prepare the design for fused filament fabrication or triple F 3D printing using Fusion 360's Manufacture workspace. Start by selecting the workspace's drop-down list, followed by Manufacture. Fusion 360's Manufacture workspace includes features for both subtractive and additive manufacturing. We'll select the Additive tab, which includes everything relevant to 3D printing. We'll start with the Setup feature. This allows you to select a machine from the Fusion 360 library. If by chance you do not see your machine listed here, you can utilize the generic FFF machine profile, which can be customized to your machine specifications. As an example, I'll select my Ultimaker S5. Next, we'll need to define our print settings. This is where you will define the desired type of 3D printer filament. You can leverage Fusion 360's library of pre-existing filaments, as well as save filament modifications to your local library. Be sure to select the correct size and type of filament that will be loaded into your machine. Upon selection, the filament type will be listed in the dialog. Double-check that the operation type is set to additive. This will default to additive when you create a new setup from within the Additive tab. Lastly, we'll need to select individual components, the assembly, or the manufacturing model as the model to 3D print. I'll toggle open the manufacturing model in the browser and select the entire assembly. Selecting OK will complete the setup and place us in the Arrange feature. Fusion 360 supports arranging the parts in 2 dimensions as well as 3 dimensions for other types of 3D printing. We'll leave this set to 2D. Notice we can also refine a number of spacing types to define the distance between our components in the build platform, the ceiling, spacing between objects, and more. Let's leave these set to the default settings and select OK. Notice this automatically places all of our selected components on the build platform. However, we may need to manually reorient some of the parts to get their desired print orientation for triple F 3D printing. When needed, we can use the Move Components feature to manually move components around the build platform. Once a component is selected, move the item by dragging the directional arrows or by defining a distance in the dialog. I'll also select the 4 wheels and rotate them 90 degrees to ensure the longest side is parallel to the platform. When parts are floating above the build platform, we can use the Place Parts on Platform feature to automatically move them to the platform. Select the desired parts, define an optional clearance, and click OK. This moves the parts to the platform without us having to guess the distance with the Move command. I plan to print the axles with some different filament, so I'd like to remove them from our setup. One benefit to Fusion 360's Manufacture workspace is that we can edit our manufacturing model without affecting the source design file. Right-click to edit the manufacturer model. This places us in a contextual environment where edits can be made. I'll right-click on each axle in the browser, followed by the Remove command. This will remove the components from our manufacturer model without affecting our design file. Once complete, we can finish the edit state to return to our additive setup. After finalizing the location of all the parts, it's critical we check to ensure none of them collide or take up the same physical location. Collision detection will allow us to select the desired parts to check. Selecting Compute will tell us if there's a collision or not. Everything is clear of collisions, so we're now ready to add support to the car body. We can turn off the visibility of our machine in the browser at any time. This will allow us to look at the underside of the car's 3D body to determine where we may want support material. Using the Solid Volume Support command, I'll select each of the bottom faces of the car body. We can then define the desired support overhang angle, which determines the angle at which supports get generated for down-facing surfaces. I'll change this to 45 degrees. Depending on the file and the amount of support material, this may take a minute or so to process. Notice the support material that is now included on the underside of the car body. By selecting the desired faces and defining our desired support angle, we were able to avoid support being generated in critical areas such as the slots for the car axles. We're now ready to generate our additive toolpath using the Generate tool. When activating this for the first time, the toolpath will generate right away. If you have previously generated the toolpath, you may receive a warning message that one or more operations do not require regeneration. Once complete, you'll see that everything in the browser includes a green check mark. This lets us confirm that our toolpath and setup are complete. Toggling the additive toolpath will show us the print time based on our current setup. The time and additional metrics can also be viewed from the Print Statistics tool. It's here that we can also get an idea of the amount of filament used and how many layers make up the 3D print. Before exporting, you may also want to simulate the toolpath to ensure everything looks correct. Simulate Additive Toolpath allows you to animate each layer of the build. Notice we can drag the blue directional arrow to view the different layers. A color legend helps you distinguish between support, outer perimeter, inner perimeter, infill, bridge, raft, prime, and skirt and brim. We're now ready to export the file to our machine. This is done via the post-process feature. Double check that your machine is correct. You may also want to define the desired output folder. This can be changed to a specific folder, such as your desktop or downloads folder, to make the file easily accessible. Selecting Post will save the G-code, and you're all set to transfer it to your 3D printer. You're now ready to create additive setups in Fusion 360.